Starting recording. All right.
Hey everyone, we will just begin in a few minutes. We'll just let people in and we will begin the session in just about 2 to 3 minutes. All right, let's get started. Hello, everyone, and welcome to our June Convo Collective event. I'm your host, Fatima, and I'm excited about our discussion with some amazing speakers joining us from across the globe today who have volunteered their time to be with us today. So thank you to our panelists. And next slide, Olivera. Yes, before I forget, I have Olivera with me as the tech operator and Olia as the chat moderator. So thank you to both of them as well. And as you all know, Convo Collective is a volunteer-run organization, which means that we rely on sponsorship. So I'd like to thank our sponsor for the year, VoiceFlow. This year, they have supported us and sponsored us. So thank you very much. And yes, we have an extensive history working with VoiceFlow, and we are happy to have them board. If anyone is not aware of VoiceFlow, you can check them out on their website and see how you can build chat assistants with VoiceFlow. Next, please. Amazing. This is our Conversation Collective team, and I'm sure you all have connected with us or have chatted with us previously in our sessions, even out of our sessions. But yes, this is our amazing team: Olivera, Emily, myself, Meredith, Bishma, Chirag, Olia, who's also there in the session today, Louisiana, Ali, Tim, Ankur, and Marcy. Right, so if you want to join our community, you can fill out the community form and be part of our community by joining or signing up for our newsletter or social Slack channels and LinkedIn. Furthermore, you can also learn about our upcoming events by following us on Eventbrite, or you can just go to Convo Collective on LinkedIn, and you can know about all of our resources and our upcoming events. For today, we have a very tight agenda. For the first 10 minutes, we will start with the introduction. And for the next 40 minutes, we will go through the panel discussion. And the last 10 minutes, we will take any questions from the audience that you have. Now, before we begin, I'd like everyone to introduce themselves in your chat. In the chat, tell us where you're joining from and what brought you in here. You can also drop in your questions and feel free to ask any questions to our panelists. You can also speak during the discussion and ask your questions, or you can just drop them in the chat. I have also pulled a lot of questions that we have received from the registrations, and we will address those questions also. Next slide. Now let's dive in. So I'd like to start with some introduction. Our today's topic is neural HCI, AI chat assistants, and conversation design best practices for brain-machine interfaces. And we have an amazing line of panelists. So I'll just ask our panelists to begin introducing themselves. So Eros, if you would like to go first.
Yes, good morning, everybody. Thanks for coming. I'm Eros Marcello. I'm a design engineer specializing in deep tech. I've been working in the realm of AI ML for close to 10 years and neurotech for since around 2017, more or less. I've worked at companies like Apple, Meta, Salesforce, ServiceNow, and Samsung in varying capacities. A lot of conversational AI and human interfacing, multimodal artificial intelligence with global deployments and shipments. I'm Silicon Valley based, and my company, Black Dream AI, is a startup, and we are situated right on NASA Ames Research Park property in the heart of Silicon Valley and Mountain View.
Thank you, Eros. Anusha, if you'd like to introduce us to the audience.
Sure. Hi, everyone. Thank you for being here. I'm Anusha. I'm based out of Austin. So everybody from Austin, hey. From work, I am currently working on building customer support chatbots for healthcare clinics. But apart from work, something I think that would resonate with the listeners today is, and that's something that I'm working on is I'm an interdisciplinary researcher. And I think empathy is a word that resonates with every designer in multiple forms of definitions. And I am trying to pursue the definition from a new perspective, by understanding how mirror neurons enable us to empathize with each other and further learn how we can use this information to make chatbots better listeners. So yeah, if anybody is interested to learn more about it or learn more about my work, feel free to reach out on LinkedIn.
Awesome. Thank you, Anusha. Stephen, if you'd like to introduce us to the audience.
Hey, everyone. Thank you for coming. My name is Stephen Gross. I have been in the conversational AI space for about 4 years now, working at Instacart, which is a grocery delivery company, really focusing on like the customer support space and chatbot space. Really just like, yeah, learning how to understand people's problems and figuring out, all these utterances and how people are saying things and saying it differently, and really trying to boil down to the intent of what their actual problem is. So, ready to talk about this awesome topic.
Awesome. Thank you so much, Stephen. Yes, I think we are really grateful to have you all today here. And I don't think I introduced myself. So yes, I'm Fatima. I'm also a freelance conversation designer with extensive experience in building and designing chatbots for the last 4 years for enterprise clients. And yes, here I am. I am a part of this amazing community, Conversational Collective, and we connect with like-minded people, and we host events on a monthly basis. So here we are starting with our discussion today. And for the first question that I'd like to pose to Ross is, what is the most significant, from your perspective, what is the most significant advancement in the neural HCI that has happened recently, and it'll also help facilitate communication between users and brain-machine interfaces? Like, what is your perspective on this particular?
Yeah, so I'll say that BCI has the brain-computer interfaces, neural interfaces have the potentiality to introduce, in this case, dry or wet dry EEG as a modality and medium of input for these action models, language models, language vision models, large multi models. So I'll say the proliferation on a consumer level of neural interfaces right now, regardless of their quality, and given that they're not technically touted as medical devices, therefore, ideally they'll do no little to no harm if they fail or are overpromised. I'd say that's really where everybody's looking right now in the near term, for many reasons. So I'll say that's I think the biggest potential spot, that the biggest value potential of this. this point.
Right, right. That's a great point. Anusha, what are your thoughts on a significant advancement that has happened recently in neural HCI? And how does it facilitate communication between users and brain-machine interfaces?
Um, I think one of my, if I can say, favorite part of neural HCI, not necessarily neural HCI to be exact, but I think Hume has done a great job in identifying emotions or and trying to empathize with the user. And they have used a lot of data to identify different kinds of emotion just from your voice, that is from your pitches and tones. And I think this is just the beginning, like literally just the beginning of what more we can do. But yeah, so I think Hume has done a great job. And I think we still have a lot more. Yeah, Hume AI. Yeah. Thank you for sharing that earlier. So yeah, I think we still have a lot more progress to do on how we can also teach the bot to have the same, you know, response based on users' emotions. I think that is something that is yet to be achieved. So yeah.
Right. That's a great example, Anusha. Thank you for sharing with us. And we'll definitely, I think audience would love to take a look at what Hume AI has done in this space. Stephen, what is your perspective on neural HCI, and what do you think that it facilitates communication between users and brain-machine interfaces?
Yeah, I think kind of like Anusha was talking about, like the mental health space, I think is a ginormous opportunity. I know there's chatbots that are kind of in that space that are almost like working as therapists right now. Like an example is Wobot, I think is one of them. But just like this ability for these machines to learn and understand emotion, through text, but then also through voice. And then also I heard this example of one where they can detect your eye patterns as well, to see if there's, any anxiety or depression, things like that. So I think like the mental health space is somewhere where it's really going to make a huge impact on people's lives.
Yes, I think that's true. I mean, the mental health space right now for everyone is really important, considering our lifestyle and considering all the factors that we are living in right now. So absolutely, and also thank you for sharing WooBot example. I follow WooBot, and I also learn a lot of conversation design best practices from that particular chatbot. So yeah, that's great. Amazing. So my next focus would be on LTCNNs, which is liquid time neural networks. So Ross, what do you think is the importance of LTCNs in the process of temporal data for brain-machine interfaces? Like, what is the importance of liquid time constant neural networks and in the development of the brain-machine interfaces?
Yeah, so that's what I'm working on currently, at what I'm doing. So liquid neural networks or liquid time constant networks they hold a lot of potential in the realm of open domain robotics because of their need for a time series data, and in this case video, or EEG for a neural language model or a neuroscientific foundation model of some kind. So that's really exciting. When you think about the fact that neural networks adapt post-training and then can be deployed, they're much friendlier when it comes to architecture and power consumption. So if, again, stood up correctly, they hold a lot of application when it comes to edge and on-device ML. And that's really where we're headed for reasons of privacy, sure, but more so for reasons on the other side of the aisle, which is tracking in new situational arenas and events.
Sorry to interrupt, Ross. I think there is some disturbance. Is it only for me?
Yeah, everything.
Okay, I think we'll just wait for Ross to come back. Anusha, can you share your thoughts on this particular topic about LTCNNs and what is the importance in processing temporal data?
I might not be an expert in this question, uh, but I'm looking forward to the next ones.
Sure. Any ideas from you, Stephen?
Yeah, probably the same thing. I think my area is more in like the conversation design and all that, so I'm not sure about the liquid neural networks.
No problem. I think we'll head to another topic, which is also about the best practices in conversation design. So, Stephen, I think you can answer this really well to talk about the best practices in conversation design for brain-machine interfaces. Like what, from your experience, what can be some of the best practices that can also be used for, these machines which can be used in probably mental health space or the healthcare space or the the neural HCI as well.
Yeah, I think one of the best practices that I'm finding a lot recently is this combination of like NOU, like intent-based, rule-based bots, and then also integrating generative AI. I think there needs to be a good balance, especially when it comes to mental health and all that stuff, because you don't want too many biases sneaking in there and all these answers being made up with people who are looking for very specific help in various hard places and hard mental states. But at the same time, like you want it to have that personality and that conversational flow that makes it easy for them to interact with. So I think right now that's kind of my go-to advice is finding that balance for your industry or whatever you're working in, is to have that balance of very like intent-based, rule-based, structured conversations, and then also like not just going full force on the generative AI side, but also like integrating it a little bit so that you do have some of that empathy, conversational flow. So it's not just one or the other, but a good combo of both.
Right. So you mean to say that we need to be more focused on the NLU and NLP side rather than just being relying on the Gen AI or the LLMs that we have integrated with the chatbots. I think that's a great point, because when you are dealing with people who are actually within the mental space, then you need that kind of empathy and also that kind of control in the conversations that can, not go further and just be within the particular space. Right.
Yeah,
That's a great.
it's a very critical space for those biases to not creep in, I feel. So anything you can do to kind of mitigate those biases, which I don't know if we'll talk about that later. But yeah, I just
Yeah,
think it's to kind of have a good mix of both.
yeah, absolutely. Anusha, any thoughts on conversation design best practices for this particular space?
Yeah, something that I have been working on is error recovery, error in chatbots. And I think I was at one of the conference that was happening at UT Austin, which is very close to me. And there was a poster as well on the very same topic of error recovery, which can also be handled by asking questions instead of a hard stop, right? So yeah, that has been a little bit of a challenge, but I think how do you ask questions? What kind, like, how do you know which question to ask at an error stop is something that I think could improve the conversation a lot more. Uh,
Mhm.
so yeah.
So you're saying for the fallbacks and errors, we need to have kind of a follow-up method for the users. And that's what can make our conversation design a little bit better when we are designing for such use cases within the neural and the healthcare space. Right.
Yes.
That's what the point. Yeah, I
Yeah.
get that. Yeah, absolutely. I think that's really important for when you're designing for errors or for fallbacks. So yeah, Eros, if you're back, we'd like to know your thoughts as well on this particular topic.
Yeah, so human computer interaction best practices for this are going to be largely ambient first. That's where, if you look at how neurotech is being leveraged in the design or HCI spaces accordingly right now, it's really for, again, providing that medium, that temporal medium for predictive maneuvers, and precognitive maneuvers, which really don't require um, tactile design or tangible design, where if a conversational agent is present in the loop, it doesn't really need to necessarily say anything. More so when you have neural data, brainwave data, the hope is that that itself can actuate certain things, certain different benefits, use cases itself, or intents that can be an intent activator on behalf of the user. So.
Yeah, that's a great point, Ross. And on this particular topic, I had a really interesting question from one of our registrations. I'm not sure if that person is in the session today, but I'd just like to ask that question is that what do you think this tech will do for someone with Alzheimer's or schizophrenia in the next 5 years?
Not much. As far as what it'll do to alleviate symptoms, there's everything from precision neuromedicine and neurotherapeutics to neuromodulation. What it'll do, okay, let me rephrase that answer. What it'll do at scale from just the pace of research, of the research domain, and then FDA, when you're talking about schizophrenics, when you're talking about anybody who's actually has disordered neurological phenomenon occurring, you're in the medical domain, so you have the FDA and their ceremony that you have to go through, which is extensive, and that's to avoid harm first and foremost, but also it's regulatory, so you have and government, so you have a lot of you have a lot of bureaucracy and processes for the sake of processes you have to go through. So as far as the impact, that's what neurotech is championing over traditional neuroscience. Neurotech is seeing an exodus from a lot of folks from the academic domain because they want innovation to leave a paper or a laboratory. So that's really important, and that's what neurotech is. Neurotech is applied neuroscience. So, but again, timetables really are affected by regulation. So something to keep in mind.
Right. No, thank you for sharing those thoughts. And I completely agree with your point when you say, like the amount of bureaucracy that we have within the healthcare space and within the even within the government. I mean, it's all regulated and it's all systematically moved. So, I mean, I understand that, technology integration can be a little bit difficult. And I think we need a lot more efforts also from the company's side and from everyone's side. So yeah, I mean, that's a great point, Eros. Coming to my next question is more on the
Just a
research
second,
side.
Fatima, can I add something to that?
Sure, Anusha, please
Yeah,
go on.
I was really excited to see the question, to hear the question actually, because I understand about the regulations and how it goes back end, but there has been, like, when it comes to stuff like Alzheimer's or schizophrenia, I think early detection is key, right? And I have been speaking to somebody from University of Strathclyde who was working on research related to this.
Okay.
And yeah, there has been close to promising research on identification of Alzheimer's through speech patterns. That is, everybody has a speech pattern, right? Like the frequency of words and the usage of words. There's a lot of things that can identify future Alzheimer's. And I think that is pretty good. Even if you can identify Alzheimer's at the very earliest stage,
At early
that
stage, yeah.
still helps a lot, right? Yeah.
Yeah, absolutely. I mean, that kind of a technology is amazing to have when you can detect a particular disease at an early stage, and you can just take action against or take action to just work on that particular disease. So yeah. Thank you for sharing that, Inusha. I'd love to move on to my next question, which is more of on the research in conversation design. So where do we need more research? Is it in conversation design? Is it in temporal dynamics or AI integration? I mean, anyone like you, Anusha, you or Stephen, anyone can answer this question. Stephen, if you would like to take this one.
Yeah, I think it is going to kind of depend on the use cases that people are working with. I think that truly like user research is really the best place to start, understanding the problems that people are having and because it's going to depend on industry, even if you're working in, customer support, what's their platform, like their issues are going to vary. So just understanding your user, like what problems they're having and kind of like having that empathetic approach. To really understand what they're going through and even how they interact with other things in their daily life. I know this example where, someone was interacting with someone with a blindness and they were like, oh, turn 180 degrees. It's like, well, they don't know what 180 degrees is. So, like having an understanding of, their lives and the people you're interacting with and building this technology for, I think is really like the base of where all research needs to start and be done.
Right. No, that's good. I think I agree to that point as well. Like, just getting into more of user research and getting into understanding of how the users will behave in a particular scenario is also important. So, Eros, from your perspective, where do we need more research? Is it within conversation design or temporal dynamics or AI integrations?
Where we need more research, research is a constant, ever continue. It's a continual thing. So it's not like one research needs to be done in one area more so than the other. At this point, I'll say more so where these where your neural data and where biosensing can really provide value again are these serving as these actuators for experience. So not every experience needs a conversation. So some some user queries need action, some need direct information, some need links or means to self-service. I mean, the sky's the limit. And when it comes to neurotech, where it can actually end up in enterprise, there's already a lot of concern about not just the ethics of it, but whether again, there's a huge there's a huge amount of debate going on in using BCI non-invasive BCIs to track an employee for enterprises to track their employees' progress, but with that, not only is it actually invasive when it comes to it from a privacy standpoint, but then you have you know the noise and artifacts inherent in something like dry EEG and whether alterations in my brain waves versus your brain waves during a task, those the reasons for that could be many, not necessarily lack of focus or lack of attentiveness. So again, there's a lot of there needs to be a lot of validation, and when it comes to research, there's been so much fraud in academia lately, especially as of late. So many papers have been recalled. I think it's somewhere of 3,000-4,000 that are at least counted. So when it comes to research, it's more so again about these ambient first concepts and areas because that's what we want. We want to shrink the user experience. We want to mute the user interface until it's essentially ambient anyway. So that's where it comes to like using neural waves to make more robust eye tracking for predictive behaviors. That's a real thing. Actually, someone I know is working on that.
Wow.
So there's just a lot in the ambient HCI space, more than just neural HCI that I think is neural is an actuator and an avenue. Neurotech is an actuator and an avenue for much more personalized and conducive experiences.
Yeah, no, I think those are some really great points, Ross, and thank you for sharing your experience as well as your expertise into this particular area. And yes, so I'd love to hear also from Anusha. Even you have been into the research space. That's what you mentioned. And do you think that we need more research? Is it in conversation design or is it for AI integrations or temporal dynamics?
Because I come from the customer support domain, something that we also have been trying to tackle is the memory problem. That is, how do you remember customers' previous data so that you don't have to ask the same the same questions that they have already shared, right? I think Zep AI is doing a great job with that, but again, it still has a lot of challenges, and there's a lot more work to be done on how exactly do you remember the data so that the conversations are as relevant as possible, right?
Yeah.
So yeah, I think that is a very interesting space that I would like to delve into going forward as well. Uh, but yeah, please do look into Zep as well. They are doing a great job. That is a great example of what it would look like if memory was also incorporated into the language models, and it has, I think it has an 80% success rate compared to the other language models. So yeah, that's
Wow.
definitely something to look into.
Right. No, so by memory, you also mean to say that, it needs to retain the context
Yeah.
of the conversation that the users are having. Yeah, I mean, that's also something that companies are, trying their best to do. And within, I think, neural HCI, it is more important because then we are dealing with users who are sensitive and who are also, like we need to take care of them at a specific level. So yeah, that's a great point, Anusha. And thank you for sharing examples. I mean, I love examples all the time. So yeah. Right. I think about my next topic of discussion will be on utilization of large language models for efficient BMI communication. Eros, from your perspective, how much has been the utilization of language models or large language models or small language models has been done right now for brain machine interface, communication?
I mean, I know it's being discussed. That's what I'm actually specifically working on. I was so I am looking into small language models for edge AI deployment or for edge deployment on these neural interfaces, particularly your lower count, higher noise consumer BCIs, and to see if any of that is actionable when it comes to the fidelity of the data that it captures and their consequential SDKs. But when it comes to liquid time constant neural networks, again, that needs that temporal time series data, which EEG is. So I would say that that's really where the potential that at least I'm exploring is. EEG, so raw, unfiltered, suboptimal EEG for these lower count, higher noise neural interfaces, if it could be optimized with generative AI. Because if that can be proven, you can make more bespoke, discrete neural interfaces, which mean users can use them more habitually in more places, wear them more so. You could focus more of the hardware design on aesthetics so that they're either more discrete, again, more discrete, or more of a fashion statement, more of a luxury brand. That's how neurotech is really gonna actually, not to digress, but that's really how it's going to take off on a consumer level. It's going to have to become akin to a watch, or what Tesla did with EVs. You'll have to make it a luxury, desirable item first, and then you work on cost mitigation and bringing the cost down. So there's a lot of moving parts that getting the tech right, the core
Right.
intellectual property of what I'm talking about, getting that right means for design. And that's
Right. So
it's a very,
you need
yeah.
to say about the wearables that you need to integrate into the wearables and make it like kind of a fashion statement for users. I mean, yeah, that's something very interesting from the neural HCI perspective. Right. So, Stephen, from your experience, any ideas on how small language models or large language models can be used for brain-machine interfaces?
Yeah, I think kind of what we were talking about earlier about the context. Like I think the more context we can give these things about the user that they're the users interacting with it, I think kind of the more accurate it's going to be and the more helpful they're going to be, right? Because if we're just, giving them these general prompts and these general instructions on how, to provide the users information, then they're just going to be that they're going to be general, and they may not scale even to Eros's point, like when it is luxury, it may not be a luxury, it may be more of a hindrance if it's just kind of a general thing. So I think kind of like the more context we can provide these models, then the more useful that they're going to be,
Right.
regardless of the application.
Right. No, that's also a great point, Stephen. Thank you. I'd love to move to Anusha. Anusha, if in your experience, what do you think are, I mean, is there an example of a technology that that can be running on microcontrollers which can be used for medical devices? Do you know of any example of any technology as such?
Um, nothing off the top of my head. But I have seen some very interesting research going on at the MIT Media Lab. Um, but I can't really think of an example right now that is relevant to microcontrollers.
That can be used in medical devices. Ross, in your experience, can you think of any examples as
NVIDIA
such?
Jetson has the most
Oh,
promise
okay,
in
great.
in
Yeah, I
that
think you
regard.
posted on chat.
They have the Jetson Orin and Nano, which are highly capable and have a robust developer community around. I'd say I'd look there or I'd start there.
Right. That's okay. That's a great example. I think the audience can take a look at the NVIDIA Jetson. And then Eros, how might blind or vision impaired people benefit from this particular technology? This was one of the questions that we received from the registration. So I'd love to know your thoughts on this one as well.
Yeah, again, on a medical level, you have to go through the the red tape. But when it comes to consumer innovation, the consumer space, which has certain purview and cover and stands on certain ground that if you be a wellness app, you can circumnavigate FDA involvement, especially if it's not necessarily requisite. But I'll say that when it comes for blind folks, it's back to that precognitive computing, and you have some. I would say that that's really where we have to look, because if you can get biosignatures and biomarkers to trigger events consistently, safely. So human factors has to be involved. Human factors engineering best practices as well. You can have these things happen, and you don't even have to discuss. Like, language is just again a modality to interface with computers. This would be the same thing. You're now, instead in lieu of voice, you have EEG or other tantamount neurophysiological data. But again, you have the issue of artifacts, noise and artifacts. You have the issue of electrodes not being placed, electrodes being damaged. What types of electrodes are being used? Hardware are you using? Gel, all of that not only matters in fidelity, but in you know in data capture and how that data can actually be purposed and used in a conducive, meaningful way. So that's where we are right now. It's like, okay, we can capture the data. How do we optimize neurophysiological data? And then how do we make it actionable? Not to keep reusing that word, but that's really where the space is at this moment in consumer neurotech.
Right. That's great example from you, Ross. Thank you. Anusha, in your experience, do you see how this technology can help the blind or the vision impaired people? How it can benefit the users within that space?
Okay, so here's an interesting thing that I found through my research was that people who are visually differently abled can identify emotions slower than people who are deaf. And this was very interesting because I was trying, the research that I was trying to do was trying to understand how voice can be used to identify emotions versus how visual aids can be used as emotional identifiers. And what I found out was voice was a more stronger way to identify emotions, right? But yeah, having said that, coming back to your question, I think there's a lot of scope to help blind people or any differently able people to like see the world or understand the world around them, similar to those who who can also see. I think there's a lot of scope to be able to do that, having known what is holding them back. So I think that I'm definitely looking forward to more research in the area on how we can do that. But yes, I think that is that would be my perspective or approach towards that.
Right. No, that's great. Thank you, Anusha. I'd love to speak to Stephen on this particular question, which is how do you think we can prevent potential biases in AI chatbots or SLMs from influencing communication through BMIs? Any thoughts on this particular question, Stephen?
Yeah, again, like the context, I think, the more hard documents and context we can give these machines and these interfaces, I think the less bias it's going to have. If we're telling it, here's this information, here's the answer to this question that someone is going to ask, and here's 100 different ways they might ask it. I think that's going to prevent that that bias from sneaking in. And then give it kind of the room to maybe give it some creativity and some conversational flow. But yeah, having more documents, more concrete evidence of this is the answer to this question without maybe like making sure there's no conflicts of or contradictions in those documents, because that is, we're humans writing these documents. Like it's going to happen from time to time. So just going through and collecting it and making like correcting those mistakes. But yeah, like as much concrete evidence as you can give these models so that they have all the context, I think is really kind of what mitigates that bias.
Yeah, no, that's perfect. I think, Ross, like the more amount of information we can give to the training models or the models that are used for brain machine interfaces is the way we can prevent potential biases. But I'd love to know from Eros as well, from your perspective, how can we prevent potential biases in AI chatbots or communication through BMIs?
I guess I don't understand where the biases would come in as far as hallucinations or generating incorrect data. There's that, and hallucinations are never really going to go away. When it comes to biases, I don't know how biomarkers could be bias or means to, they could be erroneous. They could be like neurophysiological data or adjacent data, which needs to be tracked to, there's certain neurophysiological, but there's certain other physiological biomarkers to capture if you want a complete picture of what's going on. And the reason that there could be a spike in potentials for on the, on a certain from a certain coverage area or electrode could be a multitude of many different things. Could be down to someone chewing gum or grinding their teeth. So I don't think bias really factors into physiological data, using physiological data as foundation model actuators for user input.
So what do you think are the biggest challenges? Is it ensuring ethical considerations and data privacy? Are those
I've seen so many industries destroyed by regulation and all of this ethical razzmatazz because, and it's not that things, I'm not saying to be unethical, but it's just that there's not a formulaic means or even a tangible methodology that's been proposed since I've been in AI/ML again, which is 10 years, that's not been universally applied or acted on. I just see a lot of theater going on, and that takes away from progress. It really does at the end of the day. So let's stand these things up and assess them in a uniform way so that we can assess their true potential for value generation, and then let's talk about ethics, I would say.
Right. No, that's a correct point. I think, talking about ethics and data privacy can largely be a little more on the sensitive side. So yeah, but I'd love to know from Anusha as well. Like, what do you think can be the biggest challenges within this space, like within the neural HCI or within the brain-machine interfaces technology space?
A biggest challenge, I think again it comes back to how people feel. That is, are they feeling intrusive? Like even not necessarily even with neural LCI, but also with um, visual interfaces, right? Like if you're being watched all the time, or if you know, even if it is with Alexa or Siri, if you people having the feeling that they are being listened to all the time is a
Yeah.
huge concern. And how do you ensure that people know how exactly it works, and uh, how do you make them comfortable? I think is one of the biggest challenges to get started with.
Right. So you mean to say that to have users accept and adopt to this technology can be a challenge, right? I mean, just to make them adopting these particular challenges and, having them use can be one of the challenges. Yeah. So yeah, I understand. And that's correct. And I think with any new technology, it is going to remain a challenge of adoption. So yeah, Stephen, any thoughts from your side on what do you think can be the biggest challenges for, I mean, ethical considerations or any data privacy challenge while developing these interfaces?
Yeah, I think transparency is very important. I know there's a lot of legislation happening around, what we have to tell users what we're doing, with their data, and like, hey, with the chatbot, like, hey, I'm a chatbot, that's kind of something that legally speaking we have to do now. So I think just being very transparent of here's, here's what you're interacting with, here's the information that we're using, and kind of like to Anusha's point, here's how we're using it. I think is very important because I think that that's also going to help them build trust and want to interact with it more as well. If they're like, like I don't have a Facebook because I don't, I thought I was listening and I don't really know how it works and all that stuff. So I was like, if you don't know how it works, you don't want to use it. So I think just like having that trust and knowledge, that shared transparency and shared knowledge is extremely important. Um, so just figuring out how it could be kind of a symbiotic relationship between the user and the enterprise.
Yeah, yeah, absolutely. I think that's also important to be transparent with your users and, just not be a little bit more intrusive with them. So yeah, moving on to my next question will be about, so beyond basic commands, right? Can BMIs also facilitate complex task and creative expression? I'd love to know from Eros, what do you think can brain-machine interfaces also facilitate complex tasks and any creative expressions beyond basic commands? Ross, are you able to hear me?
Oh, sorry, I was on mute. Party fell. Um, so BCI so consumer BCIs are largely just rebranded EEG caps. And it's really their software counterparts, like their dashboards, their software developer kits in the case of OpenBCI Neurosity Crown. That's what makes them quote unquote brain computer interfaces, because like OpenBCI has their open source GUI, then Neurosity has their dashboard along with their mobile app. But as far as handling complex tasks, I mean, that's sort of a loaded question. Right now, again, we're kind of in a wait and see pattern in the neuroscience, applied neuroscience domain of there's a lot of players already in this market of neural first wearables. Let's see what value that they create. Let's see how adoption goes on. So we're not even really there yet as far as handling complex tasks. Are the initial tasks that have been promised, or are the initial promises that have been made even being met? That's where we're at, and we're looking and
Right.
waiting to see and kind of sussing out the legitimate acts from the BSers. So.
Right. So you mean to say that complex tasks or handling complex tasks is still a far-fetched area? I mean, we are just dealing with the initial
Well,
task.
when it comes to encoding or decoding, on the decoding end, I mean, neurophysiological phenomenon can be very complex. But when it comes to when you're talking about decoding that information,
Right.
um, like how complex can it get? That's where the potential of SOTA models and a neuroscientific small language model or small foundation model could really. That's what we're looking into right now. So.
Right. No, that's a great point. Thank you, Russ. Anusha, any thoughts from your side on how it can facilitate, or do you think it can facilitate complex tasks?
These are actually some great set of questions. Very interesting
Yeah.
topics, right? So yeah, I think even not necessarily complex tasks or creative tasks, but even when it comes to basic tasks like conversation that we have been working on, I think Uncanny Valley has been and is still a huge factor. And again, there are two reasons why this is happening. Again, is because lack of emotional resonance, and why this is not still available is because we do not have enough research on mirror neurons. Mirror neurons research, we turns out we only found out about mirror neurons in 1996, which is like yesterday in terms of innovation, right? So yeah, I think there's a lot of uh, scope and lot of stuff that we still need to uncover and identify how exactly to first get an understanding of how exactly mirror neurons work with human interactions to be able to replicate that. Um, so yeah, I think to be able to tackle Uncanny Valley, I think that is something that we need to learn more about. And that is what I'm trying to work on as well for the rest of the year, and more as well if if needs to. So yeah.
That's great. Thank you, Anusha. I think you can also share your research whenever you are ready with it. So yeah, I think we are on the last 6 minutes, and I'd love to know questions from our audience if we have any. Please post in the chat, or you can also speak up,
I
like
have a question.
unmute yourself. Oh, I think we, no problem. So you can just unmute yourself and you can ask a question to our panelists. And we have a great set of panelists who's, giving us ideas and examples on neural HCI and brain-machine interfaces. So if anyone has any questions, please do post in the chats and we'd love to address them. Okay, I don't know where this.
Seems like it's coming from Mitchell, who had a question, and I think they're trying to diagram their question right now.
Oh, wow. Yes,
Is it right, Mitchell? Would you like to unmute yourself and ask and
you
just,
can, yeah, you can unmute yourself and you can ask the question. Please go
or
ahead.
maybe just in going with the theme, maybe there is no need for language.
Yeah, thanks, Olya. Olya, I think you had posted a question for Eros. Is that correct?
Yeah, I had one about the great examples of wearable EEG tech that's like fashionable and maybe Lynn's luxury that Iris could give us.
Yeah, Neurosity Crown, I'd say, when it comes to
Those two.
aesthetics.
Mhm, mhm.
Yeah, Neurosity Crown when it comes to aesthetics. I think that's where that's where they're sort of innovating in. So that's what I would that's the immediate point. And then you have AOAI, which I think was spun out of Google, and then you have this other company, the name escapes me, but they have this ear-based neural interface, and it's like a little earring. So I would
Who's
say
it
those.
by? So, who's that?
I'm
Is
trying to
Google?
remember. Yeah, I'm trying to remember exactly who was doing that. But that's, I think, surrounding the orbit. Apple filed a patent recently for neural sensing AirPods. So there's been a lot of hubbub about that. And also, you know, how much, it's a great place to capture neurophysiological data, the earlobe and ear canals, but how much and how much noise, what type of artifacts are introduced, different sized ear canals, different structured ear canals, et cetera, et cetera. So, yeah,
Right on. Thank you. That's a great answer.
those would be the three.
Thank you.
Neurosity crown is where a good place to start. Yeah.
Yeah,
Thank you.
thank you. Thank you, Russ. And thank you, Olya, for the question. Right. Do we have any more questions from our audience? Our panelists would love to answer any questions that you guys have.
I have another question if no one else has.
Please go ahead.
I was curious about Neuralink. It hasn't come up once in this conversation. So where Neuralink is on the scale of innovation and how they contribute in the in this space.
Neuralink is, I mean, their first implant, I think, is largely a failure. So I don't really know where it stands. As far as what I've seen so far, they're not really doing anything particularly new.
Hmm.
And that seems to be the kind of rigmarole of the big, kind of trendy players, mainly that one in the space, is that they're kind of rebranding a lot of old science with a Elon Musk component to it. So, all I know is from what I've read, they obfuscated the fact that pretty much that entire patient's first neural lace was eventually the threads detached and it became unusable. So
Yeah, wild. Thank you. Yeah. So, yeah, it's great to have your kind of insider's perspective on what's going on with Neuralink because it made such a splash early. So
yeah, I mean, they're good people working at Neuralink. I know people at Neuralink, but it's just as far as the overall mission and then the harmonizing human and artificial intelligence, these are all very, sci-fi-esque tall orders. So
Yeah, Robert has also shared his perspective. He says that Wise Ear is also working on ear-based neural interfaces. So if anyone has any ideas on Wise Ear, they can share their perspective. Amazing. I think we are at the hour and we had some really good discussion. Thank you so much to our panelists today, and thank you all for joining in. Please do share your feedback with us over LinkedIn or over an email, and we'd love to hear your thoughts on this. Thank you so much, everyone, and we will see you all next time. Have a great summer. Bye-bye.
Thank you all. Bye.
thanks.
Thank you.